Turbulence sent a Singapore Airlines flight plummeting 6,000 feet without warning. One man died and 30 others were injured. So, what went wrong? Could climate change mean we'll see more of these events? We'll be joined by a scientist who spent a decade researching just that, and also the head of the Airline Pilots Union, BALPA. And this is Paula Venables, who's at the heart of the post office scandal. She finally gives evidence tomorrow. And we'll be asking Lord Arbuthnot, who played a pivotal role in the Postmasters campaign, what he wants to hear from the woman who was in charge. Also tonight, will tomorrow's inflation figures give the government a boost, or are cost of living concerns so endemic will it even register? Our economics experts will give you their answers. And tomorrow, the MP Craig McKinley returns to Westminster after revealing the extent of what he describes as extreme surgery after sepsis.
There was discussions happening about these arms and legs, because by then they had turned black. They were like a plastic. You could almost knock them. And it was like your mobile phone plastic.
Tonight, Olivia Giles, who also had her hands and feet removed because of sepsis, tells us how she's recovered. And Dr. Ron Daniels, Chief Executive of the Sepsis Trust, will tell us the signs to look out for. Good evening. Singapore Airlines flight SQ321 headed from London to Singapore did not go according to plan when the plane was hit by severe turbulence over Myanmar and dropped dramatically and unexpectedly. One passenger died of a heart attack. Geoffrey Kitchen was 73. 7 more passengers are critically injured. 23 more have suffered less severe injuries. Now, severe turbulence can be forecast, but another form, clear air turbulence, is harder to detect and so can be unpredictable. The BBC South Asia correspondent Jonathan Head spent the day at Bangkok Airport. Jonathan, thank you very much for joining us tonight. Tell me, what have passengers been saying to you about what happened to them?
Well, they've described what was a smooth and uneventful flight. It was towards the last stage of this flight. It's usually about 12 hours. I've done it many times myself on Singapore Airlines from London to Singapore. And in those last 2 hours before they descend to Singapore as they're going over Myanmar and Thailand, it's about the time they serve breakfast after a night's flight. A lot of people, of course, had got up to use the bathroom, having woken up. And it was that point that some say that the seatbelt sign went on. There was a little bit of turbulence, and then suddenly this incredible drop and absolute chaos. There was, people covered in other people's breakfast and coffee. A lot of the oxygen masks came down. All sorts of other debris was thrown around. I mean, people describe seeing items just floating up in the air, and of course, people who were not secured by seatbelts smashed up into the air as well. It didn't last very long, despite that dramatic 6,000-foot drop, just a few seconds. And then after that, they say a very strange calm as people sort of just dealt with the shock of what had happened. It came completely out of the blue.
So, of the people you've spoken to today, you have spoken to some of the injured, and do you get a sense of the impact that they were faced with? We know that there were kind of dents in overhead cabins, but I mean, the impact must have been severe.
For those who weren't secured, yes. I mean, most of the injuries are relatively minor, but there are people who've got fractures, severe bruising, a lot of cuts. I mean, some of the cabin crew who were then trying to help passengers had their own faces covered in blood from cuts because, of course, they tend to be moving around the cabin at that time. We don't know what the exact injuries are of those who are having to remain in hospital, but there are a number of people who will be there for some days while their injuries are treated here in Thailand. And,
of course, there was a sad death, but tell me, the passengers who are not severely injured, are they returning home? Are they going on? What's been happening?
Well, they've sent a plane here to Bangkok Airport to pick up the uninjured passengers who remained on the flight side of the airport in the last hours of the day. They've now just arrived in Singapore in the last few minutes. Speaking to some of the passengers today who are on much longer flights, one family going to Australia for a wedding, they've said they don't want to go on. They can't face a whole succession of flights. They just want to get back home again. I suspect for some of those who've been injured or were particularly shaken by what happened, they may want to cut their flying short. It's been a really sort of shocking end to a flight, and I think it's an awful lot for people to process. These flights feel very safe. Singapore Airlines is a very reputable airline, and normally its flights are enjoyable. Nothing usually goes wrong, and something like this is something that does seem to be completely unpredictable.
Jonathan, thank you very much indeed. Well, to talk about that unpredictability, joining me now in the studio, Amy Leversage, the General Secretary of the British Airline Pilots Association, who represent 85% of British pilots, and with her Paul Williams, a scientist who has spent a long time, a professor of atmospheric science at Reading University, looking at the questions about turbulence. First of all, Amy, how much of an issue is this kind of turbulence for pilots?
Well, first of all, we would like to express our sincere condolences for everyone who's been affected by the terrible tragedy today. And turbulence is quite common. Probably most of us would have experienced turbulence, but that's very slight turbulence. This kind of severe turbulence, as seen on this incident, is very, very rare. Pilots are highly trained and extensively trained. They do lots of simulator training to try and deal with these types of situations, and they've got lots of onboard monitoring equipment to try and prevent this and avoid it.
But today, that didn't happen, or last night, I should say, overnight, that didn't happen. And I wonder if, from your point of view as a scientist, something's going on here. What kind of turbulence is this?
Well, I would emphasise again the rarity of this. Fatalities from turbulence are really rare. The last one I know of before today happened in 2009, and before that 1997. So it's not even a once-in-a-year event, it's more like once in a decade. And that's because there's just not very much severe turbulence in the atmosphere. Turbulence strong enough to lift you up out of your seat if you're not seatbelted is astonishingly rare. Less than 0.1% of the atmosphere contains that much turbulence. But of course, take into account all of the planes that are flying in the skies at any given time, and one of them accidentally will find it at some point.
But I mean, you say it is vanishingly rare, but is there any evidence that it is actually becoming slightly more common?
There certainly is. I've been studying turbulence for 20 years and how to forecast it, and the response to climate change has been a particular focus for the past decade. And in that time, we've built up a lot of evidence that, for example, since satellites began observing the jet stream, which is where there is a lot of turbulence, in 1979, the amount of wind shear in the jet stream has increased by 15% because of climate change. The amount of severe turbulence has increased by 55% from 1979 to today, yes.
That's a lot.
And in future, we might see a doubling, or in some parts of the world, a trebling in the amount of severe turbulence by the 2060s because of climate change.
That is so interesting, because I wonder actually, I mean, you're talking about pilots, but I wonder if that level and that increase will actually impact the design of planes.
Well, planes are highly designed to fly through these kind of weather conditions. Planes are designed to deal with this, and pilots, of course, continually train and continually learn, and it's evident.
But do they talk? Is there chatter among pilots?
Absolutely, pilots work as a team the entire flight. So you'll always have two pilots.
Yeah,
on the
what
flight
I mean
deck.
is that in the whole kind of pilot world, is there chatter, and has there been chatter today about this incident?
Oh yeah, absolutely. I mean, pilots have a very, very strong community. We have a strong community throughout BALPA, and indeed throughout all the international pilots unions. We all work together, we all talk, we all share experience. Pilots do this on a day-to-day basis. They work as a team.
But when you hear what Paul is saying here about climate change impacting how much turbulence there is, that is going to make a measurable difference to not only training, but other aspects of flying. For example, I think now, on a flight, you're much less inclined to, after today actually, release your seatbelt, for example.
Well, this is what the pilot always says. When you get on the plane, they always say, make sure even when the seatbelt light is turned off, make sure you keep your seatbelt buckled. And they'll always say that and try to limit how much time you spend walking around the cabin. Because of incidents like these, because as much as they try to, they have their monitoring They're talking all the time, they're broadcasting to air traffic control, to other planes in the area, and they're constantly on the radios, constantly communicating. But they do say, you know, things happen and they happen quite quickly, and the best way to do that is to keep your seatbelt on.
But I think now, Paul, because of this, there is going to be more conversation now about what happens on board. If it's unpredictable, if it becomes increasingly unpredictable and increasingly common as well as unpredictable, those two things are going to change what people feel about flying.
Potentially. I mean, it is unpredictable to an extent, although we do have forecasts of it.
There were thunderstorms in the area, but maybe that's nothing to do with it.
Well, so thunderstorms, you don't want to fly anywhere near a thunderstorm. So thunderstorms do cause bumpy flights, but they can be forecast. And even this clear air turbulence is forecastable. About 75% of it we can accurately forecast up to 18 hours ahead, but it's that missing 25% that is currently unforecastable that we need to focus on.
Well, and this is presumably part of your research. As it becomes more common, we need to be able to identify that 25% that's missing. So, you know, what are you doing? I mean, you know, obviously I wouldn't understand technically what you're doing, but are you focusing on this 25%?
Very much so, and in many ways it's my career's goal to put this final 25% in the bin and consign it to the history bin so that no aircraft ever has to encounter turbulence again. It's a really challenging problem. Turbulence is the hardest problem in physics, and physics itself is very hard, even the non-turbulence part. So it's really challenging. We're working very hard. With the right targeted research into what actually is generating the turbulence, what are the mechanisms, the dynamics, I think we can do it. But we need that investment, that scientific research to happen first. And it will take a long time. It won't happen
overnight. But do you get
overnight.
the sense that the airlines and manufacturers are as concerned about this as you as a scientist are?
Certainly the manufacturers, yes. I think the airlines are more focused on remaining profitable in the current tax year. They have financial pressures. But for the aircraft manufacturers, in contrast, I mean, they are today designing the aircraft that will be flying in a few decades' time. That's the life cycle of an aircraft. It's measured in decades from design to retirement from service. And so they need to be building into their design parameters today the turbulence of the future. And indeed, I'm in touch with them, and they are doing that.
Thank you both very much indeed. Well, coming up later in the programme,